Good morning, students. Today we are going to learn memory management techniques in operating system. This is very important part of operating system, and we must understand what is memory, and then we understand what is memory management. First, we start with our first slide, that is memory management. As you can see, what is memory management? First, you understand what is memory. We work on computer, as you all know, that our all processes, all softwares opens and executed in memory. You have listened RAM and about ROM. That is all about memory. RAM is our random access memory, and which is the place where our programs and softwares are executed. So the primary duty of operating systems to manage this memory, because we got memories in very limited area, limited size. So operating system has to manage memory properly so that its utilization, execution makes proper. So memory management is a method in which operating system manage operations between main memory and disk during process execution. Means when operating system executes one process, the process execution takes place in main memory and program resides in disk. So when one program gets executed, then it is called process, and process executes in main memory. So sometimes what happens, process size is bigger than the available main memory. So operating system applies different techniques so that at a time more than one processes can be executed, and that can be provided a efficient memory space, and utilization of main memory can be kept up. So the main aim of main memory is to achieve efficient utilization of memory. When we talk about memory management, we have to understand logical address and physical address. First, we understand about logical address. What is logical address? Logical address means when the process executes by the CPU, then one address is generated by the CPU. That address is called logical address. Means CPU generates address for every process, and actually the generated address of process is called logical address by CPU and is also known as virtual address. Then what about logical address space? Logical address space means when one process has to be executed, it has some size, it demands some memory. So the size of the process means what is the actual size of memory which that process wants is called logical address space. And logical address can be changed because every process has different variant size. So this is logical address, and size of process is known as logical address space. Logical address is also known as virtual address. The next is physical address and physical address space. And what is physical address? Physical address means the actual address of the memory. Means one hardware unit is present, what is called memory unit, and the what memory unit calculates address, that is called physical address, and this is actual address. This is actually real address. And what about physical address space? All physical address means where your operating system, where really executing our process in memory, that is called physical address, means it is actual address, real address corresponding to that process. So the physical address remains constant, and always memory management unit, which is a hardware device, is compute physical address. Now when we understand about physical address, logical address, and physical address space, we come to understand memory management techniques. Here we are talking about four types of memory management techniques, which is applied by operating system. So the memory management techniques are swapping, paging, compaction, and segmentation. The first memory management technique is swapping. What actually happens when the process is to be executed, then that process is taken from secondary memory to uh, in RAM. But RAM have limited space, so we have to take out or take in the process from RAM to time, and this process is called swapping. Means what actually happens, you can see the yellow space, that is memory, and some part of memory is always used by operating system for its own functionality, and remaining user space is the space where operating system is going to execute processes. And the grace part where we can see process 1 and process 2 is hard disk, where actually our program resides, and when one program gets executed is converted into process. Here we can see we have two process 1 and process 2. And actually we have a limited memory space for execution. So what happens, operating system, how it maintains, whichever process is required, it transferred it into memory, that is called swapped in. And when that process completed its execution, operating system swapped out that process and come back into hard disk. Means the process which gets executed come back into hard disk, and which process is needed by the for the execution, that comes swapped into user space. So by this technique, operating system is going to manage a small size of memory for the big size of processes to be executed. The next technique is paging. In paging, what happens? Process which has to be executed in divided into fixed side blocks called pages, and at the same time memory is divided into same size of about pages is called frame. Means the when process divided into pages, at the same time memory is divided into frames. The size of page and frame kept same. So when one process is executed by the operating system, then when we have divided pages, so which page is required for the execution, that page is transferred into the RAM in frame. Here we can see our process is divided into 8 pages, which is a size of 2 KB. And in memory, we have only 5 frames. So what operating system will do, it transfer which page is required for execution to the main memory in the frame. So we can see at one time 5 frames are there, so 5 pages can be kept into memory, but remaining 3 pages cannot be kept. So what happened, which pages is required is transferred into frames, and then which page is not required has completed its execution, it uh, back to the hard disk. So this type of technique is called paging, where process is divided into pages and memory is divided into frames. Next technique is compaction. This is also a technique by which operating system manage memory And compaction is used by many modern operating systems like Windows, Linux, and Mac operating system as well. What happened in this technique, as you can see in the picture, we have memory space where black area is used space and white area is free space. But it is not in contiguous form, it is fragmented. One portion is used and 40K space is not used, and some portion is used and 20K space is not used. So this black and white area, which we can see, black area is used space and white area is unused space. Now, for example, if some process come about size of 20 KB, it can be allocated space. But if one process comes into existence of size 60 KB, then it cannot be allotted contiguous space because we have not contiguous space. We have 60K space, but not in contiguous form. So it creates problem when operating system is not capable to allocate contiguous space. So what operating system will do? It applied compaction, means all use space come into one side and all free space come into other side. So now we can see after compaction, we are getting 80K space free. So now when we got contiguous space, then operating system will able to allocate contiguous space to the coming process. So this is compaction. One other technique is segmentation. What happens in segmentation means what operating system will do when one program gets executed. So the part of program of is divided into modules. Like main function is in one module. Whichever processes are, whichever procedures are there, they come into another module. And some function is another module. Stack is another module. So it converts, it divides process into different modules in different size. So that is called segment. And now what operating system will do, which segment is required to execution, it comes into memory and that portion or that segment gets executed. So that is segmentation is also a different technique for memory management. So we have completed our memory management techniques, only introduction, 4 types of memory management techniques: swapping, paging, compaction, and segmentation. We have learned about swapping, paging, compaction, and then segmentation. That's it. Okay. Thank you.